super trying to get prepared for that test, which I really appreciate the effort, ladies. All right, so we're going to do 9 and 15, and I do have my notes, I think, on 15 now in front of me there. I'm in the correct room. You can see I've moved rooms. So the oldest brother, who's only 9, is rectangular babysitting the 2 little ones while my daughter and I do some after school stuff. So we'll see how long it lasts. I might be able to do till 3:15. I might be able to do 3:30. We'll see how noisy it gets out there. So let me share the right screen here. All right, so I'm going to go to number 9 to begin with. All right, so 2, 3, and make sure that my numbers are right. So is this the number 9 we're looking for, Jocelyn? Okay, perfect. Thank you. All right, so let's look at what we've got going on there. So I have x to the 4th times square root of x plus 1. So what kind of rules do we see going on there, ladies? Okay, we got a product. Okay, and Jocelyn's seeing a product and a chain. Good job, ladies. So I've got my red and I've got my green, and then I see inside the green a chain. Okay. And that chain might not be a huge deal, but it's still there, right? So we've got to deal with it. Okay. Remember, as I'm doing this, I could rewrite this, and I'm not sure which one is the better one to use at this point. So I could also write it like that to the 1/2 power. So remember, that square root and that 1/2 are interchangeable. Okay. So I could write it either way, and I'm probably going to kind of go back and forth. So I'm going to say dy dx. The good news is we're explicit, not implicit, right? So I don't have to mess with the dy dx thing. All right, so we're going to take the derivative of the red, which would be 4x cubed, and then I'm going to leave the green the way it is. When I leave the green the way it is, I'd probably use the radical notation. And then there's the plus sign. And then I'm going to leave the red the way it is, which is x to the 4th. And then I'm going to take the derivative of the green, but the green had that chain rule going on. So let's talk about that particular chain rule. If I look at the u, it's x plus 1, which means that u prime is just 1. Multiplying the inside by just 1 isn't that big of a deal. I don't really need to do it. So when you're looking at a chain rule, if the coefficient in front of and it's just an x, and the coefficient in front of it is just going to be a 1, you can kind of ignore the chain rule. But I appreciate that you guys saw that there was an inner function. So I can kind of skip chain rule this time, which is kind of nice, isn't it? Then I am going to, so I don't know why this one ended up in this unit, right? Because it has that, it's a chain rule, but it really isn't a big deal. So I'm going to take this 1/2 and I'm going to bring it in front. So it'd be 1/2. And then the x plus 1, and I'm going to subtract 1 off the exponent, so to the negative 1/2 power, and then technically times the 1 from the inside, a part of the chain rule. All right, obviously that is not the answer that is there, so we have to clean it up, okay, because it is a multiple choice question. So the first thing I'm noticing is I got to get this guy back downstairs. So we've got 4x cubed square root of x plus 1 plus x to the 4th over 2, and this is x plus 1 to the 1/2 power, and I'm going to do something kind of probably not good. I'm going to skip a step. That x to the 1/2, we could turn that into a square root of x. So I'm going to go back to that because I'm looking at all my answer choices, and that's what they all have. Anything that I've put out there could be fair game for the test, okay? So I'm answering Marilyn's question in the chat. So it could be on the test, okay? It might not be this exact one, but they might have some of the thinking, okay? And remember, I've given you a pool of about 36 questions here. So the ideas that are in these 36 could be on the test, okay? Between this one and the progress check, okay? And I think the progress check almost ended up being easier than this review in some respects, okay? All right. So now I need to get a common denominator. So my common denominator is going to be this thing right here, right? So since I need that as my common denominator, that means I need to multiply this thing on top and bottom technically by that common denominator. So I get it scaled up, and that's a 1, not a 4. All right, so in the denominator is just going to be this. So I'm not worried about that. So here I would multiply the outsides together. So I have 2 times 4x cubed is 8x cubed. And then the square root of x plus 1 times the square root of x plus 1 would just be x plus 1. And then from this part here, I'm just going to keep the x plus, or x to the 4th. Then it doesn't look like I'm quite done yet. It looks like I need to multiply a little bit more. So I'm going to distribute this in, which gives me 8x to the 4th plus 8x cubed plus x to the 4th over square root of x plus 1. Okay. And then we've got 8x to the 4th plus x to the 4th is going to be 9x to the 4th plus 8x cubed over 2 square root of x plus 1. So let's go back now and look at the answer choices we have. And I'm not quite there yet, right? I don't see this exact numerator here. I know it's definitely not D. Okay, so I don't see that exact numerator. I've got the denominator, but it looks like I might be able to factor out an x cubed. So I'm going to do that next. So x cubed times 9x, or so when I take that out, I get 9x plus 8 left over 2 square root of x plus 1. And ladies, I want you to think about this, okay? The calculus, so all of the calculus was finished when we hit this line. Okay, so that was the calculus. If you've got that down, you're doing good at the calculus, okay? All of this here was algebra. It's simplifying algebra. I'd say 80% of the mistakes we make in calculus are not calculus related. They're almost always algebra related, okay? All right, I'm going to give you a couple seconds there, then I'm going to go to 15, and we're going to finish up 15. We did part A, and then I said, hey, I need to look into part B a little bit because I needed to make sure I was going to do it right. Okay, let's go down to 15, which we kind of started already. So if you weren't here earlier, we did find the derivative of part A, or the first part, okay? So the second part here, we've got to find the points where on the curve, so where my quadruple stars are there. Where the tangent line is parallel to the line y equals negative 2x. And we decided earlier that that's going to be the same slope, okay? So because they're parallel. So I took the slope that I got in the first part and I set it equal to negative 2. So that's what we did here. And then I said, hey, I think I need to take a pause. It was also very busy in my house, so we took a pause and said, hey, we're going to finish this one later. So let's try it now. So I'm going to cross multiply, and I don't know why I didn't think of this earlier. So I'm going to actually just multiply this over to the other side. So negative 2x minus y equals negative 2 times x plus 2y. I've been doing this a really long time, and in order for me to see that, I had to step away from it for a little while, right, and come back to it to see that part. So sometimes that happens. Sometimes we got to step away from our work for a little while and then come back to it later, and sometimes a light bulb goes on. All right, I am going to go ahead and distribute the 2 and just see what happens. I'm following my rules, really not knowing where this is going yet, but I'm going to try. So negative 2x minus y equals negative 2x minus 4y. All right, not knowing what else to do and knowing there's still 2 variables there, I'm just going to try to add my 2x to the other side and check out what happens. It cancels. Okay, so now I've got negative y equals negative 4y. I am going to go ahead and add this y to the other side, so I get 0 equals negative 3y, meaning that y is equal to 0. Okay, now I need to take that and I need to go back to my original equation, which was all the way over here in the question stem. Okay, I'm going to put that 0 in there and try to solve for x. Are you talking about, Marilyn, are you talking about on this one or on the last one?
The last one.
The last one. It depends on the question. If it was, sorry, my reminder's going on. If on that last one, if it was open-ended, it wasn't multiple choice, then you could have left it right after you took the derivative, okay? If it's multiple choice, we have to simplify as far as we can until we get the multiple choice. Does that make sense?
Yeah, that makes sense.
Okay, so I will default sometimes to going all the way to the simplified so you can see it for the multiple choice piece, even though on a free response, we might just stop earlier, okay? All right, we're back up here into this, and we're gonna go ahead and put that 0 in anytime we see a y. So I'm gonna see if I can squeeze it in right here. So we've got x squared plus x times 0 plus 0 squared equals 1. I just squeezed it in. Okay, the good news is it's 0 times x is 0. 0 squared is 0. So I've got x squared equals 1. All right, which means I'm going to take the square root of both sides. And remember, when I take a square root on the right side, I want to put a plus minus. So x equals plus or minus 1, which just meant we just got 2 points. Okay. And then in our little hint, we're supposed to put the smaller x value first. So our x value was -1 and our y value is 0. Our x value is 1, our y value is 0. And these little numbers are probably just because it's my answer. I pulled the answer key one. Don't worry about the numbers, it's the response. All right, so that's that part of it. We still have to do, it looks like, find all the x values. So I'm going to give you a couple seconds to catch up. Okay, so in the next one, it's saying find the x values on the curve where the tangent is horizontal. So if we're talking about a tangent, that means we have to be talking about a slope. If our tangent is horizontal, it's a horizontal line, what's the slope of a horizontal line? Can you tell me that in the chat, please? Excellent job, ladies. So it is actually, our slope has to be equal to 0. So guess what we're going to do? We're basically going to do the same thing we did with the last one, but this time, instead of setting it equal to, what did we set it equal to? Like 2, we're going to set it equal to 0. Okay, and see if we can get that solved. So I'm going back to this derivative we had earlier. So -2x minus y over x plus 2y equals 0. All right. The first thing I'm going to do is I'm going to take this guy and I'm going to multiply him to the other side. Well, guess what happens? 0 times that mess is just 0. So I really get -2x minus y equals 0. All right, I'm going to solve that for y. So this one's a little bit crazier, okay? Because it seemed easy at the beginning, but now we can't cancel the variables like we were doing on the last one to solve for one of them. So I'm going to add the y to the other side. So I get -2x equals y. So it's going to be kind of like a substitution method on systems of equations from here. So I'm going to take this guy and I'm going to substitute him back into the original equation. So let's see, I'm putting it in for the y. So we have x squared plus x times this new y, which is -2x. And then plus, it was y squared, so -2x squared equals, it was a 1. And now we've got it down to one variable, so we can solve it. So I'm going to simplify as much as I can. It looks like I've got x squared minus 2x squared. And then -2x squared would be positive 4x squared equals 1. So it's looking like I'm getting x minus -2 is -1. -1 plus 4 is 3x squared equals 1. And then I'm going to divide by 3. So I get x squared equals 1/3. Take the square root of both sides, make it a plus minus. We know, sorry, I shouldn't write it like that. We know that x is equal to plus or minus. The square root of 1 is 1. I'm going to leave it as square root of 3. So we would write -1 over square root of 3 and 1 over square root of 3. And typically we've lied to you for years, right? Saying you had to rationalize. You don't have to rationalize your answer in calculus. Okay. All right. I am going to go to, let's see, we've done 15. So I've gotten Jocelyn's done. Now I'm going to go to 11 for Cynthia. We'll see how far we can get. Okay, so let me make sure I get to the right 11. Double check me, make sure that that is the 11 that we are looking for. Okay, great. Where is my just in case here? All right, so we are going to do the derivatives. We need to get to second derivative, okay? Was anybody see any rules going on there that we need to make sure we take into account when we're taking these derivatives? What rules appear here? All right, a chain rule. Good job. So we've got a chain right in here, right? And it's kind of hidden because we didn't have parentheses, but they like to do that with trig, like not type the parentheses. All right, so I'm going to go ahead and say that my u is equal to 5x, which means that u prime is equal to 5. So I'm just going to rewrite. So f of x equals tangent of u plus x squared. I'm going to take the derivative of that. So f prime of x equals, all right, what's the derivative of tangent of u? Big hint. Look at all the answer choices. So I'm looking for the derivative of there we go, secant squared. Perfect. All right, so that's secant squared of u, and then I need to multiply by the derivative of the inside, which was 5, and then plus the derivative of x squared would be 2x, and then I need to clean that up and put my u back in. So I'm going to move the 5 out front. So 5 secant, I'm going to write it a little bit different, of 5x squared plus 2x. I did that on purpose because now we need to take the second derivative and look at what happened. I've got a chain rule and I've got another chain rule. Okay, so it's like the peanut butter, more importantly, the peanut butter M&M, right? That's better than the peanut one, right? Or the Tootsie Roll Pop with the wrapper on the outside. Okay, so I'm going to go ahead and do my chain again. All right, so I'm going to still use u just because that's what we're familiar with. So u is equal to secant of 5x. And then I know before I can do that one, I'm going to have to come up with like w. So w is going to be equal to 5x, which means that w prime is 5. I'm going to go back to my u because I'm chaining backwards. I'm rewriting this one as secant of w. I'm going to take its derivative. All right, what's the derivative of secant? Tell me in the chat, quick. And in multiple choice, the nice thing is I can kind of use my answers to help me out a little bit. So I'm looking for the derivative of secant. Okay, secant tangent. So it is there. Good job. So we've got secant of W, tangent of W, and then I got to multiply by the inside, which was 5. And then I'm going to rewrite it. So I'm going to put the 5 in front. I'm going to replace the W with 5x. All right, and then we got to chain all the way back to our original now, right? So f prime, I'm going to rewrite f prime equals 5 times u squared plus 2x. I'm going to start taking that derivative. So the derivative of this here is going to be 10u plus or times the derivative of the inside, which was this huge mess here, 5 secant 5x tangent 5x. And then we still got to do the derivative of this 2x, which is the plus 2. And now we got to plug the u back in. So f double prime of x equals 10 times the u, which is this mess here, right? Oh, not this mess. This mess here. So secant of 5x, and then it's 5 times secant of 5x tangent of 5x plus 2. All right, now we've got to clean that up. So I've got 10 times 5 is 50. Secant times secant would be secant squared 5x, and then just tangent of 5x plus 2, so it looks like the last one. All right. All is quiet out in the other room there. So do you guys, it's almost 3:15. Do you ladies want me to keep going as long as I can go? Because I still got 1, 2, 3, maybe 4, 5 of these problems you guys want. Is that okay if I keep going? Yeah? Okay. Absolutely. And I'm going to do the best I can to get, if it's still quiet out there, since I don't have to go pick up little boys, I'll try to get the videos posted right away too. Okay. I might even edit it and put it in the right order. We'll see. I don't know if I'll get that fancy. All right, so 4, 3, 1. So let's go to 4. All right, so number 4. So looking at the hint, it says we're going to need to factor out common factors for the final answer. The AP exam loves that. Okay. All right, so what rules do you guys see going on in here? What rules are going on in this guy? I think we just have a delay this afternoon. On the upside, the Santa Anas haven't started yet, right? Because we're supposed to get Santa Anas today. All right, so I see, because I'm assuming you guys are tired. There we go. I've got a product in the chain. There we go. As soon as I try to start saying the answer, it always pops up. All right. So we have the red would be this function, the green would be this function, and inside the green, there's a chain. Remember when we did the last test? Actually, the last test was on the product, the power, and the quotient. The new one in this unit was the chain. So you're going to see chain rule a lot in this test. Okay, it's going to be all over the place because that was one of the main things we learned in this unit was chain. Okay, so we're going to take this derivative, and good news is it's only first derivative. So f prime of x equals, so I'm going to take the derivative of the red, so 2x. Leave the green the way it is, 2x minus 5 squared. And then put a plus sign. Keep the red the way it is, so just x squared. All right, now I've got to do my good old chain rule. So I'm going to do that off to the left here. So my u is going to be equal to 2x minus 5, which means that u prime is equal to 2. All right, then my outer function, if I look at that outer function, is going to be, now it's going to be like u squared. So its derivative is 2u times the inside, which is 2. So if I fixed that up, it would be 2, or it should be 4, right? 2 times 2 is 4, times the u, which is 2x minus 5. So that's actually your derivative of your green. times 2x minus 5. All right, I want you to take a look at this. I want you to take a look at what's in the blue. I want you to take a look at what's in the yellow. So it's a weird greatest common factor, okay? What do we notice that we could take out? And it's really, really weird. So what are some ideas about what can come out of there that's in the blue and in the yellow? And even if you don't get them all, give me an idea. Give me something. Okay, I like the 2x minus 5. That's really good, Marissa. Okay, Cynthia sees an x. All right, is there anything else we see? It's a little bit more hidden. Look at your coefficients. Not the square. Okay, I like the 2x because there's a 2 hiding. Look at this. There's a 2 hiding inside that, isn't there? It's not obvious right off the bat, but there's a 2 hiding in there. So we're going to take out actually a 2x times 2x minus 5. Talk about a crazy greatest common factor. So 2x times 2x minus 5. So when I look at what's left behind, so I'm going to look at what's left behind in the blue, I would just have one of these guys right here, right? So I'd have a 2x minus 5 left. If I look at what's left in the yellow, so I'm going to put the yellow back here. It's hard to write in the yellow. So it's still plus. I would have an x left. I would have a 2 left, and that's it, right? So now I'm going to combine like terms in this back piece. So 2x times 2x minus 5, and then 2x plus 2x would be 4x minus 5. Look at that craziness. But this is one of those when you get to the AP test, they like to do this on multiple choice. Now, granted, I didn't give you a multiple choice here, but I did give you the hint, hey, take out the greatest common factor. Because when I was looking at where I stole this from, they went all the way like this because their intent is to help you practice the multiple choice. But they when you do this, you do the product rule, and then you even get it to this line here, and you go, what on earth went on? Where did they get that 4x minus 5? It's because of that greatest common factor piece. So always be on the lookout for that. All right, I'm going back to the list. I got to do 3 and then 1. All right, let's look at number 3. We know there's got to be a chain rule.
Question.
Go ahead, Marilyn. What's wrong?
For that one question that we just did, number 4, yeah. I got a whole different answer, but it was right, and I'm not sure like which one.
Probably because of the way it auto grades. It will grade an expression that's that's equivalent. Does that make sense?
Yeah.
Yeah, and I can't change that, unfortunately, so I can't make it like exact just grades, but I can. But so just know that when it's okay that whatever you got is probably fine. It's just when if it did go to a multiple choice question, the answer would look like this.
Okay.
Okay. All right, let's take a look at number 3. Okay, so we've got a chain rule going on there. How many chain rules do we really have going on there, though? Can you tell me in the chat, how many chain rules do I have? Yeah, this is a 2, right? This is a peanut butter M&M. Okay, so we have this chain, and we have the inner chain there. And I would probably rewrite this thing as sine of 2 theta squared, or not squared, to the 1/2 power, right? So let's start doing our u, right? Start doing the chain. So u equals sine of 2 theta. And then I got my w. My w equals 2 theta. So w prime equals 2. I'm going to rewrite my u. So u equals sine of w. And then u prime equals the derivative of sine is cosine of w. And then I got to multiply by the inside. And then I've got to rewrite it, right? So u prime equals 2 cosine, I'm putting in the w, 2 theta. All right, now I got to chain all the way back to the original. So f of theta. And it doesn't matter that it's a theta versus an x, or a t or something. It's just another variable. And I tend to do that when I do trig. All right, so I've really got u to the 1/2. So f prime of theta equals, I'm going to take the 1/2 and I'm going to bring it in front, which is going to give me u to the negative 1/2 times the derivative of the inside function, which was this mess, 2 cosine of 2 theta. Before I put the u back in, I'm going to go ahead and make this guy come downstairs, because that's what the negative exponent does. Keeping the 2 cosine 2 theta upstairs. Check this out. My 2's are going to cancel. That's kind of nice. I'm going to rewrite that with a square root over the top. And now I'm going to substitute the u back in. So the square root of sine of 2 theta. All right, how we doing, ladies? Are we doing okay? All right, I'm going to go a little bit more. If you guys decide you're done, you tell me you're done. Okay, and I stop. All right, let's do number 1. Okay. All right, so what rules do we have going on in number 1? Okay, we've definitely got a product. Technically, we have a chain, right? Technically. But that chain is only going to produce the 1, right? So there's really no point in me doing the chain rule piece. Okay, so really this one didn't need to be in this unit because it's not producing a chain rule. It's really going to give us much of a result. I should have left this one in unit 2. All right, but we're going to try it anyway. So let's see. We've got this is the green, red, this is the green. And I could rewrite my green as x plus 1 to the 1/2 power. That's going to be useful at some point. So, and they're using the dy dx notation. So keep the red, or sorry, take the derivative of the red, 3x squared. Keep the green the way it is, and I tend to keep the square root answer. So x plus 1. Then we're going to use the addition sign. And then we're going to keep the red the way it is, x cubed. And we're take the derivative of the green. And my guess is after this piece is where it was the algebra, not the calculus. So I'm going to bring the 1/2 in front. And I'm going to subtract 1 off of it. So I get x plus 1 to the negative 1/2 power. Okay. I'm going to clean that line up a bit. So we've got 3x squared, square root of x plus 1. Plus, there's an x cubed in the numerator. The 2 goes in the denominator. This is x plus 1 to the 1/2 power, or I'm going to be sneaky about this. I could just write it as the square root of x plus 1 because I'm looking at the answer that's there and I'm going, ooh, it's got the square root in it. And we saw this pattern before in an earlier problem. And AP does love this thing. Okay, this is what they will put it multiple choice. All right, so I need that common denominator again of 2 square root of x plus 1, because that's the only denominator I have, which means I am multiplying this top and this bottom of this first one by the square root of x2 over the square root of x plus 1. So the denominator just stays as this. I multiply the outsides together, so I get 6x squared. And then I multiply the inside. Square root of x plus 1 times square root of x plus 1 is just x plus 1. And then this guy here just gets dropped down because it's already over the correct common denominator. All right, now I'm going to distribute this in. So I get 6x cubed plus 6x squared plus x cubed over 2 square root of x plus 1. All right, and then it looks like I can put my cubes together as like terms. So 7x cubed plus 6x squared over 2 square root of x plus 1. And again, this is one of those lines. If I left it open-ended, I would personally have you guys stop in this line right here. okay? If it's open-ended, we don't go further so we don't make a mistake. If it was multiple choice, we simplify it. We have to simplify until we get the answer, okay? And I've seen the answer there, so I know, hey, they wanted us to simplify more just because they were mimicking a multiple choice on this question. So I see an x squared in both of these, so I'm going to pull that out. So x squared, I'm left with 7x plus 6 over 2 square root of x plus 1. All right, I'm going back to my list because I think I got Cynthia's done. All right, 13 and 14 are the last two we wanted to talk about. All right, I'm going to give you a couple seconds there, and then I'm going to scroll.
Mrs. Ballard?
Yeah, go ahead.
The answer says something else.
X squared plus 3. What happened? I don't know. Maybe I typed it wrong. Let me look. Let me see what I did because I have the answer key here, the typed out answer key. It does say plus 3. Product rule. I agree with them there. I agree. Let's see. Where did they get the 1/2 x from? Oh, I know where that's at. 2. We've got x. So we got the 7 part right. It's the in front of the x squared part that we don't have right. Plus 3.
I think the answer key has a typo because it is a 6.
Yeah, it looks like a 6 to me too. And I don't know. I'm gonna go with the answer key has a typo, but I'm gonna give myself some stars on that one because I want to double check that. So I'm gonna make sure I come back to that, and I'll double check it for you guys. Okay. So I'll have an answer for sure by tomorrow if it's one way or the other. Okay. That way I don't waste our time right now trying to figure out where the mistake is. But we got the process right now. I want you to focus on the process, and that's an algebra issue, right? As long as we got the calculus right, that's the main focus right now. Okay, I am going to go with, we had to do, I think it was 14 and 15, is that right? Let's see. So 13 and 14. Okay, so 13 and 14, I'm going to scroll. I don't know if we've done one of those before or not. Let's see. 13. We have not done 13 yet. I'm going to see if I can squeeze it in. Okay, we've got x's and y's mixed together, so it looks like I need to do some implicit differentiation. Okay, it also looks, check this out, it looks like there's a product rule hidden in there. They're good at hiding those, aren't they? So I'm going to start by taking the derivative of my red with respect to x. So dy dx, keep the green the way it is. And then I'm going to add, right? Add. And then I'm going to keep the red the way it is. Y. All right, what's the derivative of e to the x, ladies? Good job, e to the x. Awesome. All right, and then I am going to take the derivative of, and e to the x, technically dx, right? Because I have that x and that exponent, and that's technically a chain rule, okay? But again, the dx, it goes away. All right, the derivative of negative x would be 1 dx, and then we know that the dx just becomes 1. All right, and then I have the derivative of y squared would be 2y dy dx. It honestly doesn't matter which direction you pull these. It looks like by me looking at the answer that we went to the left, that you could go to the right. You just might have to mess with your signs a little bit. So dy dx, I'm going to put the e to the x in front of it. Minus 2y times dy dx equals. And then I'm going to move both of these to the other side. I'm going to subtract the y e to the x, and I'm going to add the 1. You'll notice that they don't like negative leads, so that's why I put the 1 in front. I'm going to factor out dy dx. And that gives me e to the x minus 2y equals 1 minus y e to the x. Oops, I don't know why I wrote a parentheses. And then we're going to take that ugly mess that we've got here, and we're just going to divide by it. So my final answer, dy dx equals 1 minus y e to the x over e to the x minus 2y. All right. Hopefully we're doing okay. All right, I want to say 14 we've done. So I videoed 14. So here's what I want you to do. I will post all the videos and then go watch 14. I'll put a text message out when I post all the videos. Go watch 14. And then if you still have questions on it tomorrow, we can do it tomorrow, okay? So remember, I will be there during intervention is actually for third period tomorrow. So I'll be there at 8:35 in the morning. Oh, there was a part C. Okay, let me go do part C. And then I will also be available after school if we still need it. I'll be there for a little bit. Okay, so let's find part C. There we go. You guys are right. There was a part C and I missed it. Okay, so let's refresh what this one was about. Let's see, was this the one with the massive table thing? No, it was consider the curve. Okay, it was probably on this page over here, maybe. There it is. Okay, so let's see, we had a curve. We needed to now find the coordinates of each point on the curve. Oh, they changed the curve on this one, right? I don't think it changes the derivative though, because the only thing that changes in here, and I didn't know when I was typing it if it was a typo. Do you see how the only thing that changes is the 3? It used to be a 4, and no matter what, that's going to give me a 0 there. So it's actually the same derivative. I should have probably just changed it to 4. So we're still going to use that dy dx. Okay, so I'm not going to redo the dy dx. All right, so I'm going to rewrite the dy dx here so we have it kind of so where we can see it. So we've got, it was y minus 2 over 2y minus x. All right, where the tangent line is vertical. Okay, so if I have a vertical tangent line, that means that it is undefined slope. Okay, so vertical tangent implies an undefined slope. If I have an undefined slope, that means I've got a vertical line, which means that I've divided by 0. Okay, so really where I would have a vertical tangent is where this denominator is equal to 0. So I'm going to set the denominator equal to 0. All right. So, and now I'm going to solve for the x. So I'm going to add the x to the other side. So I know that x is equal to 2y. In order to solve, I'm going to go back to my original equation. All right, and I'm looking at what I did. Okay. I used this new equation, even though it had the 3 in it versus the 4. So I'm looking because I borrowed the problem from somewhere else. So even though it had a different number there, we're going to use that one. Okay. But it would still have this same derivative. All right. So I've got 2, and instead of x, I'm going to write 2y plus I've got y squared is just going to be y squared because we're not substituting them for y. And then we've got minus the 2y for the x times y equals 3. So 2y times 2y is 4y plus y squared. 2y times y is negative 2y squared equals 3. And then let's see, I've got y squared minus 2y would be negative y squared. And then we've got plus 4y. Since it's looking like it's going quadratic, I'm going to move the 3 over by subtraction. And then I'm going to divide by that negative 1. So basically, I'm swapping all my signs. That allows me to get rid of the negative lead, because if I can avoid a negative lead, I will. Good old magic x. So 2 numbers that multiply to 3 and add to negative 4. Which I believe is negative, no, it's going to be negative 3 and negative 1. So we've got y minus 3 times y minus 1 equals 0. I'm going to do zero product property. So y minus 3 equals 0 and y minus 1 equals 0. So y equals 3 and y equals 1. So those are my y values. I still need to plug in to get my X values. So I'm going to find where I got to plug into. I probably need to plug into, I could look at this. I could plug into here, couldn't I? Actually, I could even plug into, I don't know, can I plug into there? 3y. Yes, I could even plug into this guy right here. That might be even better. So I've got that X equals 2 times 3 is one of them, which gives me 6. And so one of my points is 3, 6. And then my other one, no, it's not. It's the other way around. It's 6, 3, because my X is the 6. And then my other one is 2 times 1, which equals 2. So my other point is 2, 1. All right. I think we've done it, ladies. So if there's any others, I appreciate the fact that you guys skipped around and it looks like you actually made a good attempt at it. So I really appreciate that fact that you're trying it ahead of time and coming in and asking the questions. Okay. All right. So I will see you all probably tomorrow sometime. Okay. So have a great afternoon and take a little calculus break because some of you have done a lot of calculus today. Okay. You're welcome, Jocelyn. You're welcome, Cynthia.
Miss Valerie?
Yes, Marilyn.
I'm just a little worried because I solved like most of them and I got a certain answer and it says it's right, but you solved it a different way and you got a different answer. So like I'm worried like on the test I'm gonna think that's how the way I did it was how you do it, and then your way I kind of forgot it. So
remember that I always go through and I look at your work.
Yeah.
Okay, so your work is super important. Okay, so make sure you're showing me all your steps and how you're solving the problem. And I want you to make sure you go back and you're actually double checking. And I don't know what's going on with the system, why it's grading stuff, right? And it's probably because it might just be the way I'm inputting. Okay. Did you get, like on this last one, did you get the numbers that I got?
I only solved part A and B on that one.
Okay.
It's like the other, I forgot which one it was. It's like number 1, I think. That one, yeah. I got a whole different answer. And then on number 4, I got like, I think a distributed answer. Because I got like x cubed something.
Okay. If it's equivalent to it, that's why. So it's probably an answer that's correct. But it just not, I might have simplified a slightly different way. Okay. So like I said before, like see where I have it boxed in black there? That's the calculus. If you've got that line right there, you're doing exactly what you should do. Okay. And I want you to actually, if it's not multiple choice, that's actually where I want you to stop. Okay. Does that make sense? If it's multiple choice, you're going to probably have to go to something. You have to figure out the algebra to get you there. So you would have to answer what the last line is probably. Does that make sense?
Yeah.
Okay. So I would just practice going through on those ones. I would practice going through and making sure you understand the steps I did just in case. Okay.
Okay. Thank you.
You're welcome, kiddo. Have a good afternoon.
You too.
Okay. Bye.